A bisector is a line or a segment or a ray that cuts a segment in half. So if this is a segment, you could have a ray that cuts a segment in half. You could have another segment that cuts a segment in half, or you could have a line that cuts the segment in half to create two equal segments. A perpendicular bisector is, if you have a segment, a perpendicular bisector is perpendicular to make a 90-degree angle and two equal parts, or equal segments. So a perpendicular bisector could be a segment, a ray, or a line that cuts a segment in half. Okay? So example 1 is AB, and that should have a mark over it, is the perpendicular bisector of CD. That means that CD is being cut in half. Not AB, CD is. So if CD equals 63, so I'm going to draw that in, solve for x and provide justifications. So these two segments are equal. I'm going to put a mark in here since there's not a point, and we'll call that F. So this means that CF, the distances are equal, is equal to FD by definition of perpendicular bisector. Next part is if I know that CF is equal to 3x plus 1 and FD is equal to 5x minus 2, that's by substitution. Next I'm going to solve for x. So I subtract 3x from each side. So that is the addition property of equality, or it could be the subtraction property of equality. So I have 1 equals 2x minus 2. So I'm going to add 2 to each side. Again, that's going to be the addition property of equality. It's getting really messy. So I have 3 equals 2x, x equals 3 halves by the division property of equality. An angle bisector is, if you have an angle, it's a ray, because it starts at the vertex, that splits an angle into two equal parts. So an angle bisector, if you have an angle, the bisector is going to be the ray that puts the angle into two equal parts. So the first one, WR bisects angle AWB. So draw AWB and label A. W has to be at the vertex B. WR is a ray that bisects it. So that means that these two are equal. If the measure of angle AWR, oops, I forgot to draw R in. The measure of angle AWR is x, and BWR is 4x minus 48. Find x and provide justifications for each step. So I know that these two angles are equal. So the measure of angle AWR is equal to the measure of angle RWB by definition of angle bisector. So then I can take x and 4x minus 8. So x is equal to 4x minus 48 by substitution. Now I finish off the algebra. So I subtract 30x from each side, so you could either write the subtraction property of equality or addition property of equality. It doesn't matter. Make sure you add property of equality though, whatever you choose. So I have negative 2x equals negative 48. Then I divide both sides by negative 2 by the division property of equality. So I'm left with x equals 24 is my answer. Okay, similar to the last one, this time we have a picture. NQ bisects angle DNB. Solve for x and find each angle measure by providing justifications at each step. So we can start by, if we know that NQ is the bisector, then we can say the measure of angle DNQ is equal to the measure of angle QNB by definition of angle bisector. Now we can substitute 2x plus 10 equals 3x minus 7 by substitution. In the next lines we do algebra. So we get their x's on the same side. So that was a subtraction or addition property of equality. So I'm going to have negative x plus 10 equals negative 7. Then I'm going to subtract 10 from both sides. So I do the subtraction property of equality again. You might have solved your equation differently too. So I have negative x equals negative 17. So x equals positive 17 by the division property of equality. But don't forget, you might have to go back and find the angle measures. So to do that, so just make sure you read the directions. To do that, plug 17 in to here. So it's 2 times 17 plus 10. 34 plus 10 is 44 degrees. I don't have to plug 17 into the second one because I know that that one has to be 44 degrees as well, because they're equal by the definition of angle bisector. Okay, some review problems. Use a protractor. So a 72 degree angle. So you can do that. 72 degrees. Make sure you label it. Make sure you have arrows at the end. Number 2, DEF is a straight angle. So it's a straight line. And E has to be the vertex. The measure of angle DEG. DE, gotta draw G off here, is 80 degrees. Find the measure of GEF. So this has to add up to 180 to make a line, so GEF has to be 100 degrees. So that's my answer. Okay, I have a number line asking for capital letters. This means the distance between A and C. So I go over to A and C. C's at -1, A's at -7, so the distance is 6. There's 6 units between the two. The distance between A and D, A is at -7, D is at 3, so 7 plus 3 is 10. There's 10 units. CD, the distance between here and here is -1 to 3 is going to be 4 units. And the distance between B and C is also 3 units. So, yeah. Okay, name opposite rays. Opposite rays have the same endpoint, they just go in different direction. So if I have an opposite ray of ray BD, BE is opposite. Okay, even though that BE is going to the left, you still have to make sure your notation goes to the right whenever you write an array. Okay, vertical angles. Vertical angles are 2 angles that form from intersecting lines. So here we have intersecting lines, and we have a couple sets of vertical angles. Okay, one set are these yellow ones right here. So to name the yellow angle, it's angle ABD is congruent and vertical with angle DBE. The second set are these green ones. These 2 are vertical, so now I have to name these angles. Angle ABE is congruent to angle DBD. I didn't even notice there's 2 D's on here. DBD That's weird. By the vertical angle theorem. Okay, skew lines are non-coplanar, so they have to be on a different plane, and they never intersect. So a pair of skew lines are, I could use, this one doesn't have a line either, so we'll call this H. Skew lines can be GH, put a line symbol, and FC. It's a pair of skew lines. Parallel lines are on the same plane, and they never intersect. So I'm going to do BC is parallel with the line PA. There's a whole bunch of different examples for skew lines and parallel lines, but these are the ones I picked. And parallel planes are two planes that are parallel to each other. So you can pick the top and the bottom, or the right, left, the front and the back. Make sure when you name a plane you use 3 or 4 letters with no commas and nothing above it. So G, E, F is parallel to P, A, B on the bottom.